Hey, what's up, guys? This is Cheng here again. This time 1792, maximum average pass ratio. Okay, so there's a school has a classes of students, and each class will be having a final exam. And you're given like a 2D integer array classes here, where there are two elements in it. The first one is the pass number, and the second one is the total number. And basically, this means that in each of the class, you have this kind of total students, and this pass number of students will pass the exam. And then you're also given like an integer of actual students, uh, who are really brilliant students, right? And this actual students are guaranteed to pass the exam of any class they assign to. And you want to assign each of the actual students to a class in a way that the average pass ratio across all the classes is maximum. So the pass ratio of a class equal to the number of students of the class who pass the exam divided by the total number of students, right? And the average pass ratio across all the classes is the summary of the pass ratio of each class and divided by the number of classes. Okay, and then we need to return the maximum, right? So for example, we have three classes here, right? In class one, out of 2 students, 1 will pass. So in class 2, out of 5 students, we have 3 students will pass. And out of 3, the third one, basically all the students will pass the exam. And then the actual student is 2. Okay. So so for this problem, so we have some observations that we need to make first. We need to make, right? So obviously, it doesn't make sense to add actual students to the class that all the students will pass, right? Because they already the pass ratio for this one is already 100, or it's already 1, right? And if we add one student to this class, so 2 divided by 2 equals to 3 divided by 3. So the pass ratio will not change, right? So which means that we want to add this student to a class that can increase the pass ratio. And the second observation is that it doesn't really matter as long as we add like extra student to any of the class, the pass ratio for that class will always increase. Because for example, if we add this one student to the first class, so the pass ratio will become from 1 divided by 2 will become to 2 divided by 3. Right? And if we add one more, right? So this one will become to 3 divided by 4, right? And the pass ratio, this is 0 0.5, 0 0.666, and this is 0 0.7, right? It's always increasing, basically, right? But the percentage of increase is different. Basically, the percentage of the increase is decreasing. So now the problem is that with this limited actual student, which class we can add? We want to add it to, because let's say for example this one, we have class 1 and 2, right? We can choose either add to class 1 or class 2. In this case, we add these 2 students to class 1. That's why the final answer is this one. After adding 2 students into class 1, we have 3 divided by 4, right? And then class 3 divided by 5 plus 1 divided by 3, we have this number. Okay, and the constraint is like this, right? We have 10 to the power of 5. So I think it's kind of obvious that to solve this problem, we also need to use a greedy approach here. Basically, every time when we assign this extra student with the current extra student, if we can find the class that will increase the most by adding one of these brilliant students, then that's the class we want to assign this extra students, right? And so how do we know that then what's going to be the increase, right, by assigning the current student? So for that, we can use a priority queue, right? So in Python, we use a priority queue. Basically, the key of the priority queue will be the increase, right, of the current class, right, by having one of the brilliant students right? And we want to use basically a max priority queue in that sense, because we want to get we want to find the class who can increase the most, right? And to do that, we have to use some negative values, right, in Python to do that, because in Python the priority queue by default is a mini queue. So now we have our approach here. Basically, we initiate the priority queue, right, by looping through by each class, all right, right, and we add the increase to the priority queue along with the p and the t for each class. And when we calculate the increase of the rate, right? So for example, so how do we calculate? So the increase of the rate is what? Let's say for example for class 1 here, it's gonna be at the beginning we have 1 and 2. So the next stage will be 1 plus 1 divided by 2 plus 1, right? Which will be this one minus 1 divided by 2, right? So this is the increase, the potential increase of the ratio by having one more brilliant student, right? And then we simply just need to store this information we in the priority queue. And since we're going to use inactive values to get the max value, we can simply reverse these two, right? Yeah, I think that will be the idea here. We use a priority queue to maintain the potential increase, the ratio increase for each of the class, and then we loop through, we do extra students times of the priority queue push and pop, and in the end we can simply summarize what's left, right? What's left in the priority queue, and then we summarize that and divide it by the total number of classes. Okay, cool. So let's start coding here. So we have priority queue here, to populate the priority queue, right? So we have a P and T, right, for each of the classes, right? And then we do a heap queue dot heap push, right, to the priority queue. Like I said, the values of that is going to be the key of the value, the key of the where the sorting, where the first element of the priority queue will be the potential increase, right? And since we're going to store the negative values, we do a p divided by t minus p plus 1, right? So because that's going to be the next state, right? And then t plus 1. And then we also need to store the p and t along with it, because we will need that to calculate the next stage, right? So this one basically, and as you guys can see, so this p plus 1 divided by t plus 1 will always be greater than this one. No, that's why this one will give us like a negative values, which is exactly what we need in this case, because we need a max q in this case. Okay, so now the next thing is that while extras, we can basically assign each student to the class, right? This one is greater than 0, right? So we're gonna do a heap pop, right? So the first one is we don't need actually. So p and t, all we need is p and t heap q dot heap pop, right? And then priority queue here. Basically, this heap pop will give us the class that who can increase the most, right? By having one extra student. And after doing that, we have a p plus 1, right? And then we have a t plus 1, right? Because we will increase, and after that we push it back to the priority queue, right? Heap push. Basically, this is the new state of the current class, right? Similarly, we just need to copy and paste this one. Okay. And then don't forget to decrease extra students by 1, right? Okay. And after that, we just need to return, right? First, let's do a length of the classes, right? And we can simply return the this total sum of the pass ratio, right? We can use this p and t, right, to calculate that. So we have to do a sum of the p divided by t, right, for this one p t, right, in the priority queue, right, and then we divide it by n, right, because after its while loop, what's left in the priority queue will be the final state, right, after assigning the actual student by using this greedy approach, right, and then we simply just summarize the pass ratio for each of the class and then divide it by the number of classes. Yep. So accept it. Yep. So passed, right? And so the time complexity for this one, yeah. So we have extra students here, right? And so let's say that we have n classes here, So this is n, right? N plus what? N plus this one, the actual students. Let's say the actual student is m here, right? And here we have n here. So n plus m times log n, right? Yeah, there's another n here, but okay, so 2n basically, but still it's n plus m times log n. So this is going to be the total time complexity for this problem, right? And the space is all of n, right? So we have a priority queue. Yep. So I think that's it, right, for this problem. It's just you just have to be able to figure out, to use a priority queue to track basically the current optimal solutions, right? And then we just use that same approach to assign each of the brilliant students to each of the class, right? So I would say it's a priority queue plus greedy approach, right? And other than that, I don't think I have anything else we want to talk about here. And so I'll just stop here. Okay, thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.